Hello everyone, welcome again. Today we're going to have a look at the grade 12 November 2020 question paper 1 for mathematics. So we're going to take a look at question 11, which focuses on probability. So like I said on the previous video, which I'm going to attach on the link below, it is important to make sure that you read all the statements when you're dealing with probability and make sure you're understanding each word in there. It's not about getting the real life system or event that they are trying to describe, but if you follow, or you can try to shrink the events to just event A, event B, if you don't understand the event to an extent that you can see it in real life. But what is important is to get the tiny piece of information that might link you or might lead you to the answer. Alright, so we're going to have a look at question 11. Like I said, the statement reads as follows. Harry shoots arrows at a target board. He has a 50% chance of hitting the bull's eye on each shot. Okay, so like I said, he's shooting to a target board. Some of us may not even know what is a bull's eye, but is that the point of the question? No. So he's shooting, 50% chance of hitting the bull's eye. We can simply shrink that to event B, event called B, so bull's eye. The first question, 11.1. Calculate the probability that Harry will hit the bull's eye in his first shot and his second shot. Alright, so I want to give you just a glimpse. So in probability, there are many ways we try to sort of draw a picture of the possible events that might happen on whatever scenario we're describing. So we use Venn diagrams. I'm going to look into that and upload a video about Venn diagrams sometime. Venn diagrams, we use the tree diagrams, we use tables, or we use just the mathematics that is around probability. But what is good is to always choose or look at the question and think, okay, no, this question is giving me such event, this one, what will better suit, what diagram will better suit this question, or what approach can I go about to solve this question? So for this question, we are shooting something and there are possible options. And then you shoot again, there are other possible questions. We see that this is spreading in a nice form. So when we start having options and the other one changing, or we have branches, we have a possibility of getting something and not, then we can go for tree diagrams. But once it gets intense and you have to repeat, let's say 10 times the event or whatever scenario they are describing, then it's hard to make a tree diagram because it branches throughout and you might not finish, or it might take up your whole page or even 2 pages of your book. So, but for tiny scenarios, like they say, they're talking about 2 shots on this one, so we can use a tree diagram. Draw it out as soon as possible so that you don't waste time on the questions now thinking or imagining all these events in your head, rather than just looking at whatever you drew and say, oh no, this corresponds to this, and we got the right answer. So for this one, I'm going to just tell you, we're using a tree diagram because there's a possibility, there's one option, then there's another. And then we have 2 shots. So we're throwing, there's 2 possible options. We either hit the bull's eyes or not. And then we throw again, second shot. We hit or not hit. So I'm gonna say the first shot. On the first shot, so we start here. On the first shot, there's a possibility that we can hit the bullseye. We call that event P. Or we cannot hit the bull's eye. What is the probability for hitting the bull's eye? Is 1/2. 1/2 is simply 50%. And then if there's 1 over 2 here for hitting, then all possible options, when we sub for one event, or let's say for one shot, all the possible options should add up to 1. Probabilities should add up to 1. So if this is 50%, it means that there's a 50% chance of also not hitting the bull's eye. So we have another 1 over 2 in here. What happens if on the first event we hit the bull's eye and then we try to shoot again? So what will happen is that this will branch further here and here. So we hit it at the first time and then we're trying to shoot again. Doesn't mean because we hit it on the first time we're going to get the bull's eye again. No, we have a possibility of not getting the bull's eye, or we get it again there, but still the chances are still the same. When you shoot first time, you can either hit it 50% or not. When you shoot again, your chances are not decreasing. It's still 50% or 50% of not getting the bull's eye. So this is 1 over 2, 1 over 2. Same thing happens for not hitting the bull's eye. So we branch here and we branch here. We can either not hit on the first go, and then on the second go we can get the bull's eye. Then on the or we can still not get, so we can lose for 2 times. But what is important is that the question now is asking us, what is the chance of hitting the bull's eye in the first shot? Then on the second one, we hit the bull's eye again. So what I'm going to tell you once more about so probabilities should add up to 1. So if we shoot for the first time, this branch plus this branch should add up to 1. Then all possible options should also add up to 1. So if we were to draw up the possible options in here, so the rule with tree diagrams is that if you're looking at events that are in series, so one starts and the other one comes the second time, you multiply the probabilities. So if we're looking at hitting the bull's eye first time, there's a 50% chance. Then there's a 50% chance also on the second go. So what you should always do for tree diagrams is to lay out different options. Hitting first time and the second time, we call it BB. And that's just saying that we multiply this one and this one. So 1 over 2 multiplied by 1 over 2 is 1 over 4. Same thing. So we hit the bull's eye first time, the second time we don't. We can call this BN. And that is still 1 over 4. We can not hit the bull's eye first time and we hit it the second time. We have 1 over 4 and we call that event NB. Second, another option, we cannot hit it the first time, still not hit it the second time, but we still have a 1 over 4. If you sum these, this is how you confirm if your tree diagram is working fine. If you sum 1 over 4, 1 over 4, 1 over 4, there's going to be an addition to 1. So you know that this is true and this is true. So if these won't add up to 1, then you have a problem with your tree diagram. So now let's go straight to the question. 11.1. We hit the bullseye first time and then the second time. The only option here that has a bullseye that is being hit twice is the first one. Now you know that you can go back to your tree diagram and look, okay, if it's bullseye first, bullseye second, what is the probability? And there it is, 1 over 4. All other events don't have the bullseye being hit twice. So that's our answer. The answer is 1 over 4. 1 over 4. Okay. So now they're saying calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. Okay, so now we no longer have just 2 shots. So we need a third event in here. So I'm going to wrap up what we already have. So yes, to add the third event, so we started here, it branched here and here. So they are saying now there's another third short. This was short 1, this short 2, and then we're adding another short in here. So we have a short now that goes like this. So from this one, we can branch and still hit the bullseye, or we cannot hit the bullseye. Then we proceed this way. We can also hit the bullseye and not hit the bullseye. In here, we still have an option of hitting or not hitting the bullseye. Bullseye, not. Then same thing here, not bullseye and bullseye. And then in all of these, you can already tell me that there's a 1/2 chance. So let me just wrap off this. There's 1/2 chance in there, 1/2 chance in there, 1/2, 1/2. So nothing is changing because every time we shoot, there's a 50% chance that we can hit the bullseye or not. So 1/2, 1/2, 1/2, 1/2. So like I said, try to make sure you map up all possible probabilities. So you do that by multiplying through each leg to check the different options. So let's say we hit it first time, bullseye, we hit it second time, then we hit it the third time. So we have B, B, B. So what happens if we hit it first time, second time, and not third time? So we have B, B, N. So this continues. I can have B, N, B, B, N, 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 P, B, N, P, N, N, N. Yes. So throughout all of these, the probabilities are all 1/2. So we multiply 1/2 times 1/2 times 1/2. We have 1/8, 1/8, 1/8, 1/8, 1/8, 8, 1/8. So we confirm again. 1/8, you sum 8 1/8, and that will give you 1. You can just confirm that with your calculator. Let me just rub off this guy in here. So now we're in 11.2. So they're asking us, must calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. 2 important words, at least, and there's also 3 shots. So there's 3, we shoot 3 times, and also they are saying at least. At least simply means that we can hit it the first time or the second time. Because they're saying we want to check when he hits it at least twice. So it can be either exactly 2 or more than that. There's no arrangement that is needed. So it doesn't matter whether we lose on the first go and then we hit it twice for the last options. So we look here, which scenarios in here has 2 B's. 2 B's simply means that we hit the bullseyes twice. At least twice. So if you look here, there's 2 B's, and then we hit it the third time, still falls in that category of at least twice. It doesn't mean now because it's 3, we leave it like that. So we have the first one, 1/8 plus. So remember, when we look in this direction, we add. When we look at branches, we multiply. Here, you see we hit it here, we hit it here, we lost here. But we still take that probability, we add it here. We hit here, we lost here, we hit here. So at least twice, we take that one. And then there's this one, we hit, we didn't hit 2 times, so we lose that one. So this, we lose this one, then this one. 1/8, We can already see on the others, there's just many ends. So our answer is going to be 4 multiplied by 1 over 8, which is 1 over 2. That is the answer for 11.2. 11.3. Glenda also has a 50% chance of hitting the bull's eye on each shot. So there's a second person now. Harry and Glenda will take turns to shoot an arrow. The first person to hit the bull's eye will be the winner. Calculate the probability that the person who shoots first will be the winner of the challenge. Okay, so there's quite a couple of ways to take note of there. There's 2 people now, and then they're interchanging. So it's no longer the same now that we have Harry shooting here and Harry shooting again. Every time Harry shoots, there's now Glenda who's also shooting just after him. So the tree is mixed up. But the question is saying the first person who starts, let's calculate the probability that they actually win. So the first person who shoots will win and hits the bull's eye will win the game. So let's actually check now. If the first person who shot, what is the probability that they will win the game? So we have to check at each time that they hit the bull's eye. It might not be the first time, second time, or the 100th time, but the game will end when either of them hits the bull's eye. But what is the probability now that it is the first one who actually hit the bull's eye? Alright, so we can already, this is going to be too many options, but we're going to try and establish a pattern or something that might lead us to the answer. So let's say Glenda. Let's choose Glenda now. If Glenda shoots first, she has 2 options: hitting the bull's eye or not hitting the bull's eye. We understand that there's a 50% chance, 1 over 2 chance that she hits the bull's eye, and there's a 50% chance that she doesn't hit the bull's eye. But if she hits the bull's eye, then Harry cannot play. So if we start with Glenda here, then Harry cannot play because we already hit the bull's eye. So we already know that there's a 50% chance out there, 50% chance. I'm going to repeat it. When Glenda shoots, she has a 50% chance of hitting the bull's eye or not. And if she hits it, the game ends. So there's already that probability that if we go with this branch, let us not even try and consider others because the game will have ended. But now what happens if she doesn't hit the bullseye? So I'm keeping this one in storage. That's a probability on its own. That's a full probability. It's 1 over 2. But now there's other possible options. What happens if she misses it the first time and then Harry shoots? Harry has 2 options. He either hits the bull's eye or misses the bull's eye. So if he shoots and gets the bull's eye, there's a 50% chance he might get the bull's eye in there, or 50% chance that he misses. But you understand that we cannot consider this moment because the game will have ended. If Harry hits there, then the game will have ended, and we are not going to consider this probability because the first person, Glenda, is not the one who hits the bull's eye. So we want to check now that, okay, now that we are betting that Harry misses, and then we go to this branch. In this branch, Glenda starts again. She can hit the bull's eye or not hit the bull's eye. We see that. So we see that there is, if she hits the bull's eye, then we are ending that side. If she misses, then we have Harry who is supposed to shoot also. So do you see that there is a pattern in here, in that? So every time we shoot the first time, we are getting this option. Every time we shoot again, we are getting this other option in here. Same option persists in here, that if Harry gets the bullseye or not, we are betting that we are in this branch, so that Glenda can go and hit the bullseye. So we're always taking these guys. And it's the same, and it keeps on going deeper and deeper. But what is the probability at this point? It's going to be 1 over 2 to the power of 1. That's just 1 over 2. And then we have to add it to the fact that if Glenda misses and Harry shoots and he doesn't hit the bullseye, then we go here. So we have a probability of 1 over 2 multiplied by 1 over 2, and then we say we branch to this side. 1 over 2 times 1 over 2 times 1 over 2, that's going to be 3 1 over 2s. So it's going to be 1 over 2 times 1 over 2 times 1 over 2. So we have that option, but it doesn't end there. What happens if Glenda actually misses, and then here it goes? We add in here. Then if Harry goes and he hits the bullseye, then the game is over, but we're betting that it doesn't. So then we then have again another chance in here of 1 over 2. So we see that if we are to check that branch, it's going to be 1 over 2, 1 over 2, 1 over 2, 1 over 2, and then Glenda actually hits the bullseye. Why are we focused on Glenda? It's because in this choice that we made Glenda to be the one who starts the game, and we're trying to check that what is the probability that the person who started the game is going to be the one who hits the bullseye. So for the 5th time, Glenda, it's possible that she hits the bullseye, and that's going to be how many 1 over 2s? 1, 2, 3, 4, 5. That's 1 over 2 to the power of 5. And this is going to continue. The options don't end, they're going to continue. You can already see. We're going to have a point where we say 1 over 2 to the power of the infinity. Because you see that this is going to continue up until 10 years. And no one is hitting the bullseye. But when Glenda actually takes a shot, even on the infinitesimal time, so on the very, very last end, she hits the bullseye, then we add up that probability also on top of these ones. So you can already see that we're summing numbers here to infinity. And what do we know about summing numbers to infinity? We can actually calculate what is the sum of those numbers. But we need to firstly establish a pattern. Do we see that we have 1 over 2, 1 over 2 to the power of 3, 1 over 2 to the power of 5. And we do have a formula for sum to infinity. Sum to infinity, this is an exponential function. You see that these are growing with an exponent of, so this was 1, and then they added 2. We added 2 in here, so we're going to add 2 throughout. So we can already see that if we take a ratio of the second term by this one, so 1 over 2 to the power of 3 divided by 1 over 2 to the power of 1, we're getting a ratio of 1 over 2 to the power of 2. So that's what I mean when I say I'm adding 2's on every term. So just to make this neat, so the formula of sum to infinity is a over 1 minus r, where a is the first term of the series, and the first term for us is 1 over 2. Then the ratio is going to be, r is the ratio of each term. So if you can take any term, but they need to be consecutive. So if we take 1 over 2 to the power of 5 and you divide it by 1 over 2 to the power of 3, we're going to get r equals to 1 over 2 to the power of 2. We can even take the infinity number in there, and you can compute that r will still be 1 over 2 if we take infinity minus 1 and then minus 2 and then infinity. Then when we try and divide that, you'll see that the answer will remain 1 over 2 to the power of 2. So when you substitute by a, which is the first term in here, 0.5, you divide it by 1 over 2 to the power of 2. What? So, and then say 1 minus that. What is the answer? So that's going to be, the answer is going to be 2 over 3. And that is your probability. It is quite a hard question, I should say. So please leave questions below in the comment sections, and let's interact, because we're all trying to understand probability. So let's talk about this question. If you're confused at any point, let's talk about it. We'll make sure that we answer you. Please put a thumbs up, just to show that that you sort of appreciate whatever we're doing, and we can take it from there. Thank you.